Namaste and welcome back to this LCD series. Today, our story revolves around STM32 and we will be displaying our message using it on our LCD display. In the previous video, that is part 2, we used the ESP IDF platform and the ESP32 dev kit to display custom characters, ASCII, and even Japanese text. We also set our LCD foundation pillars by discussing the main controller chips datasheets in part 1 of this series. If you missed those, do make sure to check them out. At Avinashi Tech, we bring embedded systems to life. One wire, one byte, one project at a time. If you are into hands-on builds, deep dives, and code that actually makes sense, hit subscribe and join the tribe. So let's get started. First of all, you need to create a new project for your STM32 chip. In our case, that's the STM32 F411 CE U6 chip. I've already created the project here, but if you're completely new to the STM32 ecosystem, we have got a beginner-friendly getting started video for you. Check it out in the top right corner. Okay, so let me open up .ioc file. Under the System Core tab, in the Sys option, we have set debug to serial wire, which enables pins PA13 and PA14 for SWD operation. In the RCC, we have selected high-speed clock, which is crystal ceramic resonator, since we will be using external crystal. Now jumping to clock configuration tab, we have selected HSE as our main system clock source. To implement microsecond delays, we need a precise timer, so we are enabling timer 2 under the timers tab. According to the chip's datasheet, timer 2 is connected to APB1 bus. Let's verify the timer clock frequency for APB1 in the clock configuration. And yep, it's running at 25 MHz. Now, to get a base frequency of 1 MHz, that is 1 tick per microsecond, we set the prescaler of timer 2 to 24. Next up, to communicate with the LCD, we use I2C1 under the Connectivity tab. We set the I2C to I2C mode and the clock speed to standard 100 kHz and the addressing mode as 7-bit. This auto selects pins PV6 and PV7 for SCL and SDA respectively. Once the configuration is done, we generate the code. And now we simply copy our lcd_I2C.h and lcd_I2C.c files into the core include and source file directories respectively. We have already discussed the code structure and required LCD functions briefly in our previous video. So just a quick recap. setCursor function positions the LCD cursor using DDRAM addressing. Functions like sendString or LCDWrite then write data into the display's DDRAM. To display custom characters, we use the createChar function to define patterns in CGRAM and then display them using setCursor and LCDWrite function combo. There's a mapping between the values you send to DDRAM and the patterns you define in CGRAM. You send values 0 to 7 to render the characters defined via createChar. But again, due to time constraints, I can't re-explain everything here. So if you're curious, I highly recommend watching part 1 and part 2 of this series. Now, in the STM32 version, we haven't touched the core LCD driver functions. They stay intact. We have only added a few helper functions in the beginning for microsecond level delays and for I2C operations using STM32 HAL APIs. Also, since I don't want to connect a USB to TTL module just for the serial print, I have simply commented out the printf macro in the code. Let's now look at the core changes in main.c. We start the base timer for timer 2 using HAL time base start. Then the sequence is familiar. We call LCD init, enable the backlight, and display our welcome message using LCD home message function. So inside LCD home message function, we have replaced the FreeRTOS vtask delay function with a simple HAL delay. You can wrap this also in a macro if you want, but I have kept it simple. Inside the header file lcd_I2C.h, we have added the necessary STM32 specific include files. And we have removed all the ESP based headers from lcd_I2C.c file. In the delay microsecond function, we start the timer 2 counter and wait in a loop until the microsecond count is reached. Now for I2C, we import the I2C handle from main.c into our driver file. Yes, I2C is already initialized in main.c via this function mx_I2C1_init. But inside our driver, I thought to validate important members like the clock frequency and address mode before returning from init. Finally, to send data over I2C as master, earlier in ESP32, we needed multiple steps using the command handles, but with STM32 HAL, this is a single line operation using HAL I2C master transmit. We pass to it the I2C handle structure, then our 8-bit slave address, that is 7-bit address 0 hex to 7, plus our write bit, which would be 0, plus the data and its size, as well as a timeout of 100 milliseconds. And lastly, don't forget to include the LCD header files in your main.c file. That's it. We are clear to build and flash the code to our STM32 board. With our firmware file ready, let's switch to hardware mode and see what we need to bring it to life. Here's the component lineup: a 16x2 LCD display, a PCF8574 I2C IO expander module, STM32 F411 based black pillboard, a USB-C cable for power, and finally an ST-Link V2 program for flashing and debugging. The ST-Link V2 uses a USB mini connector, so make sure you have the right cable. Now I will connect the SWD pins from the ST-Link V2 to our STM32 controller, SWD IO, SWD clock, and ground. Once the connection is done, I will power up the STM32 board using USB-C cable. Now let me go ahead and flash this firmware to our STM32 board. Alright, great. After this, we are free to remove our ST-Link wiring, and it is no longer needed unless obviously if we want to debug. Now let's connect the LCD to STM32 board via our I2C expander. Alright, so I have connected the LCD to our STM32 board via the I2C expander. VCC to 5 volt, ground pin to ground pin, SDA to D7 pin and SCL to B6 pin. All set. Time to connect the USB-C power cable. And there it is, once again, Avinashi Tech. Like, share, and subscribe message on your LCD screen. But hey, this isn't just a text message. This one's for you. If you enjoyed this build and want to see more embedded hands-on like this, come on, what are you waiting for? Like the video, share it with your friends, and subscribe to the channel for more awesome content from Avinashi Tech. And with that, this LCD series comes to an end for now. Throughout this journey, we deep dived into datasheets, understood the why behind using the PCF8574 IO expander, and took our first practical steps with ESP IDF and the ESP32 dev kit. We didn't just stop at ASCII characters, we even explored Japanese characters and displayed it on our 16x2 LCD. Didn't expect that, did you? And finally, with minimal code changes, we ported the same logic to STM32 using STM32 CubeIDE and HAL drivers, making it platform independent and practical. So the message is clear, literally and figuratively. Hit that subscribe button and press the bell icon to stay in sync with more embedded content. This is Avinashi Tech signing off. See you in the next video.